All right, so new unit, we're looking at linear functions, okay, which again, it's an extension of what you did in Algebra 1. We're going to take it to the next level, right? Okay, so the first thing we have are relations. It's just two things. They don't even have to go together. Even the word relation makes it sound like they're related, okay? That's misleading. They don't actually have anything to do with each other. So we could talk about like the number of shoes compared to the number of chairs, like, right? Or to people's eyeball color, right? Like they don't have to have anything to do with each other. We're just writing out those values or quantities, okay? So we usually just put relations as an ordered pair so that you have the value of those two things. We can write it as a table, which looks like this, right? We could put it as mapping, which looks like this. Do you recognize that? Okay, so we'll talk about the mapping. We could obviously have a graph or we could have an equation. Y'all are familiar with those. Okay, so the first thing is just a reminder, x values are the domain. And so that is always going to go from the left to the right, sort of as you are reading a book. Okay, we don't ever go from right to left. We always start with the little value and work our way to the bigger value, right? Little on the left, big on the right. Okay, and then the range is going to be all of our y values. That's going to be going up and down. And I always say up and down, but it's really backwards because we want to start with the little values. So up is our bigger values, right? So when you're talking about the range, you really want to go from the bottom of your graph all the way up to the top. Okay. We're not really going to talk about this next thing very much right now. We'll get to it a little bit later. But if you have a relation with just points, sort of like what you did on the warm-up where you were just plotting points, right? Those are called discrete, where they're just individual dots. If you have a line or a curve, it doesn't have to be a straight line, but just like a solid line of some sort, that's called continuous. And we'll get to that a little bit later, okay? But it was just here for now. Okay, so a special kind of relation is called a function. This is pretty much what all of algebra is based around, right? So in a function, you are going to have each element of the domain goes with exactly one element of the range. Okay, so each x value gets its own y. Each x gets its own y. Okay, which means that the x's can't repeat, right? So like if my x was 3 and I say 3 gets the number 2, and then I had another 3 and it got a 7, right? That makes it not a function because each domain, this number 3, should only get one y value with it. We can't have another y value with it, okay? So what we're looking at to determine if something is a function or not is, do those x values repeat? Okay, which is right here. The x values cannot repeat. That's what makes it not a function. So can you see that here in our two examples? The only value we care about to tell whether something's a function are the x's. So here's an x, x, x. See how they're all different? Cool, that's a function. Over here, we have x, x, x. See how these two are the same? Mm-hmm. If those two are the same x values, that's not a function. Okay, and notice that I didn't say anything about the y's. Like I don't even have to look at the y values. I don't care. They could all be the same number for all I care. It doesn't really matter. Okay. All right, so in Algebra 1, we learn about what's called the vertical line test. So we're taking a picture of a graph. Okay, so our graph might look like this. It's called a parabola-ish, right? Okay, or it could be a straight line, it could be upside down, whatever. Okay, so we're going to take this and we're going to put our pen up against this in a vertical line. Okay, and in order for this to be a function, our vertical line cannot pass through more than one point at a time. So if I were to draw a vertical line right here, does it pass through the function more than once? Nope, it just passes right here. If I drew another one over here, it passes through one time. That's a function. If I took this parabola and I turned it on its side, like such. When I do the vertical line test, and usually, like for me, when I do the vertical line test, I just use my pen and I lay it down on my picture, right? Because as soon as I do this, I can see that it touches up here at the top and down here at the bottom, right? So that makes this not a function. But since these are our notes and I'm going to take my pen away, okay, we can just represent it with this. So if it touches twice or more than once at a time vertically, then that's what makes it not a function. So every circle, not a function, right? Anything that sort of wraps back over itself, right? That makes it not a function. Okay? All right, so we're going to talk about domain and range. For today, we are going to write our answers in, we're either going to just list the numbers like we're going to do here at first, but when we get to our graphs, we're going to put our answers in interval notation, which is the ones with the negative infinity and positive infinity and brackets and parentheses and stuff. So there are actually two ways. You can either write it like that or with the inequality signs. So for today, we're going to do interval notation, and we'll talk about the other stuff later, okay? All right, so number 1 says, find the domain and range of each relation, then determine if it's a function. Well, let's go ahead and do the function part first, because that's the easy part, okay? So in order to tell if this is a function or not, where am I going to look? At the x's. So here are my x's, bloop, 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 bloop. And what do you notice about those numbers? They are all different. So is this a function? Yes. Cool. All right, so now that we have that, we're going to write out the domain. Okay, so here are the rules for writing domain when they are just numbers. Okay, you are going to put them in order from small to large. And you are not going to repeat any numbers. So if you have like a 7 that repeats or that is listed more than once, you're literally just going to write it one time. Okay? All right, so we do these little squiggly bracket thing. Can you make that? If you can't make it, literally just make a little squiggle. It's cool. Okay? So our domain values are -1, 0, 4, and 6. So which one of those is the smallest? -1. Which one's next? 0. And then 4. Oh, look, they're in order. Cool. Okay. Bloop, bloop. Make that one backwards. Okay. Then for the range, we look at the other numbers. I'm not going to highlight them because they're the ones that are not highlighted. So of those numbers, we got to look through all of them. Which one is the smallest? -9 is the smallest. And then -5, and then -2, and then the +3. And if you need to, you could like write the numbers down just somewhere, and then as you go, you can like cross them out so you make sure you get all of them and you don't forget any or something like that if you need to. Okay? All right, can you do number 2, please? Ready, set, go.
I'm trying to write.
Santiago, is this a function? Did you get that far yet? Because there are 2 5s. Awesome. There are 2 5s, so this is not a function. So the domain is?
The domain?
-3, 5.
You caught me off guard.
You were all ready. Go ahead. -3? No, I heard you and then everybody else answered. It was awesome. Say it again, because I didn't hear what they said. I ignored them. -3.
5 and 8.
Ruben,
Oh, me?
come on, kill it.
Oh,
Yeah.
5, 8.
That's 2 5.
Oh, you don't have to list out.
Yeah. Don't repeat.
Okay.
Yeah. Because then it's just extra work. You don't do extra work. Yeah. So -3, 5, and 8, and then the other one, Jakevion.
-6, 0, 2, and 4.
Thank you. Brilliant. Awesome. Cool. Okay, so the table's the same thing. Like literally the same thing. It's just your points are written sideways or up and down instead of sideways. So again, we're still just looking at the x's. So is this a function? Yes. Do we need to write out the domain and range? Are you okay with that? Yeah. Okay, let's move on. Ding. Please send the page. Good job.
I thought that was too.
It's okay. It doesn't matter. I'm sure you did it right. All right, mapping. Yeah, the purple is really dark. All right, mapping. Here's the deal with mapping. Okay, one, it's super easy to see the domain and range. Like they're on mapping, they are already put in order for you and they don't repeat numbers. Okay, so literally this is the domain and all of this stuff over here is the range. See, they're already in order. Everything's good. Okay, so let's just write that down real fast. -4, -2, 5, squiggle, squiggle. 0, 3, 7, 9. Squiggle, squiggle.
Anyways, give me a
Okay.
challenge.
Okay, so the challenge, since you asked for it, comes in telling whether it is a function or not. Okay, how do you know?
There's two arrows
There's
coming
2
from
arrows
the
coming
five.
out of the 5.
Brilliant.
This, Miss.
Tell me.
Miss Salcedo taught us this.
2 arrows. Good, Miss Salcedo. Okay,
Yes, I
so literally this means -5, comma 7 is 1 point, and -5, oops, +5, sorry. +5, comma 9 is another point, right? So if you have 2 arrows coming off the same one, not a function. Brilliant. Okay, good enough? Okay, let's do 7. Are you ready? Did she teach you this too? Miss Saucedo.
Yeah, more than likely.
Okay, so how many of you like doing the work in your head?
Me?
Okay, how many like writing things down so you don't have to work as hard? Okay, so, okay, hold on. So, yes, telling whether it's a function or not, that's the sort of easy part. We'll get to that in a second. So, listing the domain and range here, if you want to not do all the work in your head, that's fine. What you literally just need to do is go through and write down each ordered pair. Just like we did on the warm-up, except backwards, right? So this ordered pair right here, always do X first. So we're going to go over 1, 2, 3, 4, down 1, 2, 3, 4, 5. So this point is 4, comma, -5, right? And you can write down the names of those ordered pairs, 2, comma, -1, and you can just have them all written down. And then you see all the ordered pairs. You write the numbers for the X's in order, write the numbers for the Y in order, right? Okay, but for those of us that don't want to do extra work and we want to do it in our head, you ready?
Yeah.
Okay, you can do this. Everybody can do this. Okay, on the domain, where do we start to find the domain? Up, down, left, right. We start over here at the left and we're going to work our way to the right. So I'm going to just start over here. I'm just going to put my highlighter right here and I'm going to stop when I come to a point. Boop. What number is that point at? -3. So I don't care what the ordered pair is. All I care about is the domain. So I only need the X value, right? Which is where it crosses the X axis. So that's this number right here. Yeah? -3. So -3 is my first value in the domain. Okay? And then I keep going. Now that counts for both of those 2 points. So I'm going to keep going until I come to the next point, which is way up here. What is that X value? 0. So I write that one next. And then what do I come to next? After 0, keep going. Bloop, 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 comes to 2. And then the last one is
4.
at 4. Okay, so you can sort of just use your pen or start at the left and work your way to the right. You just got to look sort of up and down through the whole graph to make sure you're finding all those points. Okay? Or you could just write them down and then you could do it. Okay, so can we do the range starting down here at the bottom? Remember, we're going to start down here at the bottom and we're going to move our way up from here. So what's the first point that we come to down here along the bottom? This very first one that's at -5. So remember, we want the y value. Oops, that's not -5. Okay, so it starts all the way down here at -5, and then we're going to keep going up. What's the next one we come to? This one, which is at -2. And then there's one right above it, -1. And then way up here at +1. And whatever that is. 1, 2, 3, 4. Okay.
Pearl, this is easy.
So, Ruben already said that this was not a function. Do you all agree?
Yes.
Yeah? Because of these 2 points right here?
Yes.
Not a function. Awesome. Okay. All right, so when it has no numbers, did she teach you this? Maybe? Let's see. Okay, so on the domain, we're still going to start at the left and we're going to work our way to the right. This is what I like to use the highlighter for. Okay, so I'm going to sort of do this. Look at my paper. I'm going to take this is for the domain. So I want to know how far left and right does my function go, right? Sometimes it goes forever, sometimes it stops. So I'm going to take my 2 pens, or I'm going to take 2 vertical lines, and I'm going to sort of box in our function. So I sort of start out like this, and I work my way to where I'm actually touching the ends of that graph. Does that make sense? And then I'm going to draw those vertical lines in with my highlighter. So this edge and this edge are sort of like a picture frame around it, right? Those are the sides. Okay, so then I look at where is that line touching the graph? So this line over here on the left is touching this arrow right here. And what's that arrow mean? Arrow means it goes forever. So this is to the left. I know the arrow sort of looks like it's pointing down, right? But this is the domain. So this arrow is going to keep going this way to the left forever and ever towards what value? Negative infinity. So my domain, the smallest value of my domain is -infinity. It goes to forever small. Okay, and then on the other side, it goes to another arrow, which is going further and further to the right, which is positive infinity. And then the only other thing that I really need to double check, now in Algebra 2, not as often that we need to deal with it as when we get into pre-cal, but we want to look for any like breaks. Like sometimes there's more than one part to our graph, right? So we just want to make sure that this is a solid line and it doesn't have any other things that it's doing in the middle there, right? So it goes from -infinity to positive infinity. Remember, infinity gets the parentheses thingies, right? No brackets because we don't know exactly what that value is. Okay, and then we do the same thing for the range. So we start all the way at the bottom for the range. Okay, so if I come up this way for the range, what is the very first part of the graph that we're going to hit? Right there. So I'm going to draw a line right along the bottom of the graph. Okay, and then I keep going up. Is it a solid line? Yeah, keep going up until we hit the very top, which is right here. And I have another line sort of up there. Okay, so picture frame around the edge of it. Okay, and then we look. What is this pink line down here touching? It's touching an arrow, which means it's going to keep going down forever and ever and ever to -infinity. And the one at the top has another arrow, which is positive infinity. And then does this pass the vertical line test? Yeah. Okay, so I'm going to give you a hint, okay, of something that you may have learned in Algebra 1. This is a linear function when it is a straight line, and it has an equation that says y equals mx plus b, right? Only an x value. So as long as you have a linear function where you have y equals something x, blah, 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 or y equals a number or something like that, it will always be a function. Okay, well, let me rephrase that. If you have y equals mx plus b, where you have x and y in your equation, it will always be all real numbers, all real numbers. Like it goes forever and ever both ways. Forever and ever, side to side, forever and ever, up and down. It's never going to stop. Okay? And it will always be a function. Okay? The only things that are going to mess that up is if our line becomes vertical or horizontal. There's a little difference there in whether it's a function or not and what our domain and range is. Okay? But every other linear function will always be all real numbers, all real numbers. Okay? For today, we're going to write our answer in interval notation. The all real numbers stuff, we'll do that another time. We do need to be able to go back and forth between the two. Okay? All right, number 9. Is this linear?
No.
Nope, it sort of has a break in it.
Not a
Okay?
function.
So, why is it not a function?
Because if you draw lines through it vertically,
It doesn't pass
it's
through.
gonna pass
Hmm.
through.
Right here, like it'll pass twice?
Yeah.
Cool. Okay, yep. What?
I was thinking like, wouldn't it like at one point not, like it would also be a function?
No, if it.
Because like if you do it on the right side, like yeah.
Over
it'll pass
here?
it, but then I'm guessing you
No,
would
'cause
have to have
you gotta
it
drive
like,
through all of it.
Because it's all
Yeah.
it's all one line together.
So, yeah, so if I drew the line over here, it only touches this part down here, but since this has an arrow, it's going to keep going and going and going, and eventually it'll cross over that. Yeah, cool, good. Okay, so domain, left to right. All right, so I'm going to come over on this side. Where is the first place that my line touches my graph? Or what is the farthest thing to the left that we have on our function?
-4.
This value right here, which cuts through -4. Okay, so I don't have any part of my graph smaller than -4. Does it equal -4?
No.
Is it like a closed circle there, or is it open? Is it touching the -4? It is. So remember, just like on this parabola thing, remember if we have this U-shaped graph, we can put like a little dot right there and we call it the vertex.
Mm-hmm.
So anywhere on that line, a line is just made up of a ton of little points, right? So anywhere along this solid line, we could draw a point that would be a closed circle or a closed dot. Okay, so it does include that whenever it's a straight line. Okay, the only time it wouldn't is if it was an open circle, and you would literally see an open circle like that somewhere along your line. Or if it has like a dotted line up to it, which we'll talk about later. You won't see that for now. Okay, so -4 is the smallest. What's the biggest? Where's the farthest over here to the right? This arrow, which is going towards forever, positive infinity. So -4 to positive infinity. Infinity gets a parenthesis. What's the -4 get?
Bracket.
So on this, we don't do this. The squiggly is only when you're like listing numbers. Like 2, 7, 5, -3. Like that's when you use the little squiggly thing.
Bracket.
So this is closed in at the -4. All right, and then what about bottom to the top? So starting down here at the very bottom, it's like off the bottom of our graph, right? With a little arrow. So that's heading towards negative forever. And what happens at the top?
Positive forever.
Positive forever. Arrows both ways, forever, forever. My infinities are beautimous. All right, so can you try the circle? Where's it go? It's not really a circle. I think it's an oval, but that's okay. We'll pretend. Number 10, please. Where's it go?
That is not a function either.
Shh, Ruben.
What?
Do it on your own
Oh.
without telling everybody. All right, so what'd you get on the far left?
Oh.
I'm sorry.
Negative two.
-2. You get -2?
Yes, ma'am.
And what do we get on the far right?
We got negative five.
+5?
Yeah. Positive.
So -2 to +5. If I wanted to, could I draw a dot there along that circle to represent that spot? Yep. So this is going to be a closed bracket on both of these, closed circle. All right, and what about bottom to top? The lowest is at -2, and the top is at 4. -2 to 4. And Ruben already shared with us, this is not a function. He's master on that. Okay, so we need calculators for this last part because they don't have a picture for us. So meet me halfway.
Oh, miss, I think it's in algebra 1.
I'm using this one.
Can I get the black one, please? Could you please? The black one,
Why does that matter?
So weird.
It's the calculator, right? Calculator number.
You got a yellow book.
Let me see.
Don't use Desmos. Don't use Desmos.
This was sloppy.
Okay,
Elbows up.
so
Miss looking sloopy.
when you're
Miss, look what someone typed on it.
when you're at home, you can use Desmos. When you are in class, we need to use a calculator. Okay? So the reason being is that when you go to college, they might say you have to use a calculator, like you can't use a computer at all, right? And I'm gonna vouch that my daughters are in college right now and they have at least 1 or 2 classes each where they have no devices allowed, like no phones, no computers, no nothing while they're in the class. Okay, so you do need to be able to use all your different technologies. Okay, so grab the calculator. We're gonna type in this equation right here. Okay, so we're going to go to a new document over here. So push the home button to get this. Then we're going to go to number 1 and have a new document. Don't ever save anything because that's dumb. Okay, and then instead of doing just a regular calculator screen, we are going to add a graph so that we can see a picture of our function. Okay, so what you need to remember is that this f of x right here is the same as y equals. Okay, so as long as your equation says y equals, you can type it in the calculator. So which one of these, Kanaya, which one of these can't go into our calculator?
14.
Which one of these can we not put into our calculator? Yeah, why?
No, not
Because it says x equals, not y equals, right? So this not in calculator, okay? Because of the x equals, we can't do that, okay? So as long as it says y equals, we can type it here. Okay, so we're gonna type in the first one, negative x squared, negative x, right, negative x squared plus 3. Negative x squared plus 3. And when you hit enter, an x squared graph should look like a U-shaped graph or a parabola. The negative in front of it makes it go upside down. Okay, so what I'm going to do just for our notes is I'm going to sketch, just like we did on our warm-up. I'm just going to draw a real quick sketch so I can get it off of my calculator. Okay, so it goes sort of like this, upside down U. It would be helpful to know where this dot is, this vertex up at the top. How far up did we have to go for that value? 3. Can you count it? 1, 2, 3.
4. Right? What do you?
Up 3. I think it's 3. 1, 2, 3. minus 3. All right, so now that we have this drawn, we can do our domain. So what happens from left to right on this graph? Is it ever going to stop?
No.
Nope, it's going to keep getting wider and wider and wider and wider. As it goes down, it's going to keep getting wider and wider. So negative infinity to positive infinity, or all real numbers, right? Forever and ever. And what about up and down? Does it go forever and ever up, forever and ever down? Nope. It stops where? At 3. So right here, it stops. So is that the big value or the little value?
Big value.
The 3 is the big value, so that goes last. And down here is our little value with these arrows, which show that they're going towards negative infinity. So infinity gets parenthesis. What about our 3? Is it going to get a bracket or parenthesis? Bracket. Okay? And is this a function?
Yes.
Because if I draw a line this way, it only ever touches it once. If it was on its side, that's when it's not a function, because it would hit twice at the same time. So yes, up and down parabolas are all functions. Sideways parabolas, no. All right, number 12. Tell me about that equation without typing it into your calculator. Tell me. Tell me something good.
That is not a function.
What does it look like?
A straight line
It
going
is
down.
a straight line. It is not going up and down. It is, because it has the X and the Y,
Oh,
it's going to be like a slanty line, right? So this is called linear. It has a negative slope, so it's going to do something sort of like that, right?
Oh, I thought you
Negative
were
slope?
14.
No. Nice try.
I was
Okay, so this is linear. It slants down like this. Is that going to be a function? Yes or no? Yes. Cool, I've already seen it. All right, and does it ever stop?
No.
Nope. So this is going to be forever and ever, forever and ever. All real numbers, all real numbers. Okay, but since we're just doing graphing on our calculator for the first time, I do want to show you a little trick. Okay, so on your calculator, okay, look. All right. Control what? No. Okay, so Control G is how you get to put another graph on top of the one that's already there. Okay, I would never encourage you to put 2 graphs on top of each other unless it specifically says graph these together. Okay, so you know how on your computer, how you can like open new windows and the other stuff still stays there? You can do that on your calculator as well. So we call this a tab. Psst, this is called a tab right here. Okay, and so we want a new tab or a new page. So right here, do you see this word doc? And right above it, it says plus page. So in order to get that, because it's in gray, I have to push my gray control button. If your button is yellow, then plus page is in yellow.
Mine's white.
And you have to push control and then doc. And it gives you this menu that we started with, and you can push number 2, and now you have a new graph. Okay, so if you wanted, we could do the negative 5x. Was it plus or minus 1? Minus 1. And it looked like that, like we said, right? Okay, let's do the next one. Let's do control plus page again, control doc. Let's get a third page. And if you wanted to, you could use this little cursor to like scroll back and forth between the pages, right? Like you could go back to one that you already did. Okay, so let's do an add graph. Can I type this, number 13, into my calculator?
Yes.
It says y equals. Great. So we're just going to do y equals negative 7. And we hit enter. And it does nothing. What does that mean?
And you're supposed to go find it.
We have to go find it. You're right. So what that means is that this line is off of this window that we can see through. So it's like if I look out in the hallway and I'm like, there are people out there, but I look out that little window right there, I'm like, I don't see any people, right? So I need to open the door or get a different view, right? Different perspective to be able to see that. Okay, so we're going to go to menu. Menu.
Bro, we all know what that looks like.
Really? And then we're going to go to number 4, which is our window or zoom. And I would just encourage you to zoom out. Number 4. And so number 4, it gives you this little magnifying glass and it says, where do you want the center to be? You can leave the center where it is. It doesn't really matter. And you just hit it once and then it sort of zooms out for you, right?
I think I zoomed out a little too much.
That's okay.
It's showing ease.
So this line is going to be like way down here, right? At -7. So any line that says y equals a number is going to be a horizontal line, okay? Which means that which one is going to be all real numbers? Which way does it go for an ever and ever? The domain
both ways.
or the range?
I mean, domain.
Range,
No, domain.
domain. This one goes forever and ever side to side, -infinity to positive infinity. And what does it do going up and down?
6.
It sits at what number?
-7.
-7, like forever, right?
Like
So we just put a little, like it's just the
it
-7.
gets wiggly by itself.
Yep. Is that a function? Yep. All right, so here's how I remember the horizontal and vertical line because I always get them mixed up. Okay, so if I were to put my pencil on y is -7, this dot right here is on the y-axis at -7, and then I draw a line through it, right? I don't want it to go the same way as the y-axis because then it would just be called the y-axis, and that would be silly. So if we do that same thing over here, because we can't type this one in the calculator, if I put my pencil at x is -1, can y'all put your phones up, please? You want me to call you out on the video?
Yes.
Mm-hmm.
I'm already.
X is -1. Where would that be on our graph? Draw it. X is -1. Please don't do that.
Dude, that's so easy.
Does it go up, down, left, right from the
It
origin?
goes up, down,
Down.
but on the left side. And
-1 goes to the left. X is -1 is going to sit right here on the x-axis,
Yeah.
and then our line is going to go which way?
Vertical,
That one,
cross.
up, down.
It's still easy, miss.
So, which one goes forever and ever this time? The domain or the range? The range, up, down, forever. And from side to side, it sits at -1. And is this going to be a function?
No.
Does it pass the vertical line test?
Absolutely not.
Absolutely not, because every single point on this line has the same repeated x value. So vertical line is never a function.
So it's not.
Okay, that would be not. Okay.
Problem.
All right. So what we're gonna do is the very next bit is like super easy. So I want to do just a little tiny bit on the next page, to go with today because
Just
someone said this was too easy, but that's okay.
Oh, that's not
All right.
it.
All right. So remember how we talked about y equals and f of x being the same thing? Okay, so this is called an equation. Look, this is called an equation. Y equals 2x plus 7. This is called a function. F of x equals 2x plus 7. It's the same thing. We're putting a value in for x, and we get out a y value, or our range value, right? Okay, so x is our input. F of x is our output. Do you hear how I'm saying it? F of x. You've heard that before, right?
Yeah.
Okay, so function notation is used when we're finding a value for the range that corresponds to our domain. So the domain is the x. So whatever value they put in here where the x is, we're just going to plug it into our equation like you just did on your last test. So this thing right here is going to go in place of the x in this equation. So we're just going to write it like such. F of -3 equals 2, wherever you see the variable x or whatever it is, you're going to put a parenthesis. And then inside the parenthesis, you put whatever your number is. Okay? So before, we just said let x equal -3, right? So it's just a different way of writing that same thing. So if you type this into your calculator, 2 times -3, or did that in your head, -6 plus 1, 7 makes +1. Okay? So the nice thing about function notation is when you look at it like this, look at my paper. I'm going to pretend like this isn't here. And if it just says f of negative 3 equals 1, look at my paper. This is your x value, negative 3, and this is its corresponding y value. So the ordered pair that would be on this function would be negative 3, comma 1. Like it tells me those values right there. Okay? All right, so let's just do a couple of these. They're going to give us some functions, whether they're linear or quadratic or they have fractions in them or absolute value. It doesn't really matter. We're just plugging a number in for the x. Okay, so let's pick one up here from 1, 2, 3, 4. 1, 2, 3, 4. Gee whiz. Okay, 2. F of 3 over 10. So we're going to use this function that says f of x. And we're going to rewrite it without the x. Wherever we come to an x, we're going to put a parenthesis, and then we're just going to keep going. So negative 5, parenthesis, minus 14. Got it, Ruben? And then inside the parenthesis, what value are we putting there? 3 over 10. And then all of this goes in our calculator. Type, type, type. Your calculator's not afraid of fractions. Ready, set, go. Do it.
It came out with special disease for the fractions.
Calculator has a disease. Negative 5, 3 over 10. Take away. If you don't type into your calculator now, don't come back and ask me for questions later because you want to be lazy and not do it now. It's what?
Minus or negative 14?
Minus. Okay, so in between two values is always an operation. In between two values is always an operation. Okay? So parenthesis implies multiplication. So there's still an operation there, right? You don't have to type it. But at the end of this parenthesis, if you put negative 14, your calculator is going to read that as multiply, right? So that's why it needs to be a subtraction sign, right? So in between the 5x and the 14 has to be a plus or a minus. Okay? So this is negative, what was it? Negative 31 over 2. That's a 3. Okay, so we would write it like this. F of 3 over 10 equals 31 over 2. Or you could change it to negative 15.5.
I think someone's at your window, miss.
All right, y'all try number 4. G of negative 7.
He running.
Do we still have to use 5x
You can't
or
tell
we
that
can use
nigga.
the
No,
other?
you're going to use G.
I'm gonna start calling you a girl, Ruben.
Oh my god.
You act like when you
I could prove I'm not.
I don't want you to prove you're not.
Okay, focus, we're almost done, y'all.
Okay, so we use GX, right?
Yep. So whatever letter is in the front,
Oh.
that's going to be what you're going to use.
Okay.
4. 4.
Do number 4.
I was locked in, so.
All right, so on number 4, when we use the function for G, this negative, is that going to go inside the parentheses or outside the parentheses? This one right here. That's outside, and then a parenthesis, and then the square, and then the plus 9, and another parenthesis, and the take away 1, right? All we're doing is we're changing the x to parentheses. And then inside of that is going to go negative 7.
So there could be a negative.
Yep. So, but one's in front of the parentheses and then one's inside. So make sure when you type it in your calculator, it looks just like that. Negative parenthesis negative 7. So this should be negative something really big. Well, not really big, but 100 and something.
100.
Yeah, 113.
Negative 100. Oh,
Perfect.
Wow, miss.
Great.
I didn't even get to look up before I said it.
I know, I heard you right. Okay, so you probably already did that in Algebra 1,
Yeah.
okay? But you might not have seen this where it wants you to do like extra stuff with it, right? So this 2 in front implies multiply. So you're going to do 2 times whatever g of 12 is. So you got to solve for g of 12, get an answer. Take that number times 2. Does that make sense? Okay, over here, we're not going to do it. Over here on number 5, what do you think we should do first? Look at 5. We're going to find f of 1. We're going to find f of -4. We're going to get both of those as answers. And then what are we going to do with them? Subtract whatever those are. Okay, so there's no way of like simplifying those together. Like we don't want to distribute or do any of that mess. No, we're just going to solve. Okay. Real quick, can you find the absolute value bars on your calculator just as a reminder of where that would be? It's beside the 9. Yeah. The little thingy. Okay. And again, fractions, don't freak out. You're just going to type them into your calculator. So you're just really doing whatever the function says. Okay? Everybody all right with that? Okay, cool.